Hello, everybody. I'm going to continue with section 4.4 today. So still talking about using percentages. In fact, that's the name of the chapter. So last time we talked about tipping and sales tax, which kind of fell into the same category because in both of those cases, we're adding on top of a total, right? Adding a tip on top of a total or adding a tax on top of the total. Then we talked about sale prices, so removing a number from the total. And now let's talk about percent change, percent increase and decrease. So let's talk, so this is, let me say section 4.4 continued. We're going to talk about percentage increase, percentage increase, and percentage decrease. So we're going to talk about the percentage increase between two amounts and the percentage decrease between two amounts. Okay. So we've talked a little bit about finding missing percents. Like I could ask a question like, let me see here. I could ask a question. Let's see. Let's see. What if I said something like, so this is kind of a throwback to section 4.3. 40 is what percentage of 200? Let's just keep it simple. So this one should be a nice round, even whole number percentage, just to keep it simple. I'm just reminding you how we would solve something like this. 40 is what percentage of 200? So if we had a question like this, then we've got some amount and some base, and then some percentage that is a relationship between the two. Either I take the percentage and I multiply it by this number and yield this number, or vice versa, right? And we have to figure out which relationship is correct. And from the way this sentence is structured, I see that 40 should be equal to some percentage of 200. So I'm thinking some percentage times 200 should be equal to 40, right? So this is the same setup that we've used where we have like percent times base equals amount. So this is section 4.3 stuff here. And then to solve for the percentage now, so I could literally call this percentage. I would say, so if I just said percentage times 200 equals 40, then the way I solve for it is I divide by 200 on both sides to isolate percentage, right? Because I'm solving this equation for this missing percentage here. It's attached to 200 via multiplication, so I use the inverse operation, which is division. Long story short, I end up with 40 over 200 over here, which I can just pop into the calculator. Oh, is there a question? Okay, 40 divided by 200, which is 0.2, so that's equal to 0.2. And then to create a percentage out of that, I have to multiply by 100%. In other words, just scoot the decimal out 2 places and stick a percent sign behind it. Okay, so this is what we do to find a missing percent given to two numbers, one being a base and one being an amount. Okay, and we can answer a question like this and say, okay, well, 20% of 200, 20% of 200 is 40. Okay. What if we wanted to know what if we wanted to measure as a percentage, measure the difference between two numbers? So not just like saying, here's a total of 200 and here's 40, what percentage is that? What if we wanted to say, so let me write this question down. What if we want to measure the difference between two numbers as a percentage? So for example, just as a quick example, what is, and we're gonna work some more examples that I'll actually enumerate, but let's say, what is the percentage increase between the numbers, let's say 50 and 60. Okay, so we're trying to figure out what is the percentage increase between these two numbers. The first thing we have to know is, oh yeah, sorry Aja, I missed your comment. Yes, I'm assuming the 20%, that's referring to the example. Yeah, I think it just came in a little bit late. Okay, so so here, what would the percentage increase be between these two numbers? So the first thing we need to consider is what is the difference between these two numbers, right? And in this case, it's easy, it's 10, right? That's the difference between these two numbers. So what we want to do is measure how much, what increase is that out of the original number 50. So we see that the difference is 10. Oops, the difference is 10. We see that the difference is 10. And now we want to answer the question. 10 is what percentage of the original number, 50? So that's going to be a very important point, is that you always measure out of that original number. Sometimes the original number will be smaller, as in this case, when we're going to have an increase, small to big. Sometimes the original number can be bigger, and you'll have a percentage decrease. The way you're going to know is the context of the problem. So 10 is what percentage of 50? That's really going to be the question that we want to answer here. So we would set this up very similar, well, exactly the same as I set up the previous one. And I'll say percentage times 50 is equal to 10. Okay, and then this one's actually going to also be 20%, right? So I'll kind of skip, because you'll divide 10 by 50 and then multiply by 100, and it ends up being 20%. But how do we answer this question? How do we answer this question? We say, oh, and by the way, it's just a coincidence that it's also 20%, just the numbers I chose. I'm trying to make these initial problems easy and come out to nice whole percentages, so we don't have to worry about rounding or anything like that. Okay. So how do we say this? What is the actual way to formulate the answer to this question? We say the percentage increase from 50 to 60 is 20%. Let's scoot that up a bit. So why would this be useful? Well, this could be useful for like if you see that, you know, I don't know, maybe gas prices have gone up or something, and you're trying to measure the percentage increase between two consecutive or two measures of a gas price, or maybe just to make more sense with these numbers, maybe you're looking at like buying a watch or something that costs $50, and then you see the price goes up to $60, and for whatever reason you want to say, oh, what is the percentage difference between those two? Like, how much did it increase by relative to this 50? Well, it increased by a whole 20%. Adding $10 in this case to 50 increases it by 20%. All right, so there is a formula for this stuff, but really you see, I hope you're saying that there's really just like an initial step of finding that difference. And then once you get to that point, the rest of it just looks like those kind of classic percentage base amount problems that we solved in section 4.3. Because really, isn't the rest of this work pretty much just that, right? Solving for some percentage given a base and an amount. It's just that initial step of finding the difference. So let me put this in more general terms, and we will build this formula that the book gives us. First of all, the absolute change between two numbers this is going to be what I called the difference a minute ago. And why does it have a fancier name? Well, because we want it to always be positive. So we say this is the absolute value of the difference. We don't want to describe a difference, a percentage increase or decrease as a negative. Like if it's higher, it should be a percentage increase. If it goes, excuse me, if it goes lower, then it's a percentage decrease. Absolute value of the difference between two numbers. So we should never have a negative percentage come out of this. And the way we make sure that that never happens is we always make sure to take the absolute value of the difference. So if you like, you know, the absolute change, if you really want like an explicit formula, not just in words here, is the absolute value of the new amount. So that in the last problem, that would have been 60, and then minus original amount. Oops, original amount. Let me just write it down here so I give myself some more room. New amount minus original amount. So last time, or rather in the problem I just did, that would have been 60 minus 50, because 50 was the original amount. And 60 minus 50 is 10, and absolute value of 10 is just 10, right? Absolute values just make the whatever the input is, it just makes it positive. So if it's already positive, the absolute value does nothing. Then what did we do after we found that 10? We set up an equation that said percentage times base equals amount, and then we divided and then transformed the decimal into a percentage. And I can do all of that in one fell swoop by saying percentage change, so maybe increase or decrease depending on the problem, is going to be equal to this absolute change. Remember, for us, that was the 10, divided by the original amount. Remember that for us, that was the 50. So this is exactly the math I did to solve for the percentage in this equation here. original amount, I divided by 50 to solve for percentage. And then of course the last step is to just change that into a percent by multiplying by 100% there. So what's my point about all this? You don't need a formula. If you understand that you're finding a difference initially, and then from there you just set it up like a problem in section 4.3 with percentage times base equals amount, then you don't really need this formula. But it's there, the book says it, and it can be, you know, I don't know, maybe you like formulas. Okay. So now that we have all that out of the way, we've constructed it. Let's actually look at some examples that I'm going to enumerate here. So I'll scoot this up a bit. Right there. So example 1. Real quick sidebar. I am going to record Wednesday's lecture and upload it to Canvas. So there's going to be no virtual meeting on the 24th. Let me write this down over here. But I'm still going to hold you accountable for knowing the material, and in order for you to learn the material, I'm going to record something, I don't know, probably tonight, and upload it. To Canvas, where I always upload the videos. So no virtual meeting on Wednesday, February 24th, but make sure you still watch the video. And the reason I'm doing that is I've got an exam to give for my trigonometry class on Wednesday. And I could, you know, I've lectured from the building before, like in a classroom in Ayers Hall, but it's just difficult to get it set up, and I have to bring like all sorts of stuff to campus to make that happen. So it's just easier for me to record the video here at home and just upload it and let you watch it on your own time. Okay, so example 1. Let's see, from the text, an on-campus organization is trying to increase its monthly attendance. Okay. And maybe they've got some data. So, all right, an on-campus organization is trying to increase its monthly attendance. And let's say they've got some data and they're trying to measure how much their monthly attendance is growing. So part A says, if after a big recruiting push, the meeting attendance increased from 25 to 38 people, what was the percentage change? Okay, so let's say meeting attendance, I'm going to kind of abbreviate this or shorten up this problem. Meeting attendance increased from 25 to 38 people. So they put up like flyers or something and they got more people to attend. What was the percentage change? So notice in the question, they don't tell you if it's a percentage increase or decrease, but clearly it's an increase, right? I mean, the number is getting bigger, right? So it's clearly an increase. So in the end, we will describe it as an increase. So let's go ahead and solve this part A, and then we'll move on to part B. Okay, so what was the percentage change? Well, first thing I need to do is find the difference between these two numbers. And I know that I should wrap it in parentheses, and I should do the new amount, 38, minus the original amount, 25. So I know 25 is the original amount because that's, well, that's how English grammar works, right? It says 25 to 38. That means we're changing from 25 to 38. 25 is the original amount. Okay. that that absolute change is going to be 13. Still in absolute values, but by the way, does it change anything here? No, because 38 minus 25 is already positive. Okay, so we get 13 there. And now I know that my percentage change, if I'm just following along with the formula, should be equal to absolute change over the original amount times 100%. 100%. And there we go. All we have to do is ask the calculator to compute that for us. So we'll do 13 divided by 25. Whoops. Is that, and then, sorry. Okay. And then we're getting 52%. 52%. 13 divided by 25 is 0.52, and then you multiply by 100% to make it 52%. 52%. So more than half of, 50%, more than 50% increase. What would the percentage increase be if it straight up doubled? Like, what if they went from 25 to 50 people? Then that would mean we would have a 100% increase, right? So that might be something you want to note, that if an amount doubles, then that is a 100% increase. That's not what we had here, right? This was just a 50% increase. All right, part B. Let's move to part B. It says during the third meeting, so this is first meeting is 25, second meeting is 38, and then during the third meeting, only 31 people attended. Okay, during the third meeting, only 31 people attended. What was the percentage change from the second meeting to the third? So it's going to be now that we have more than two meetings going on, more than two quantities, we're going to have to be very careful about what percentage change they're asking for. And they say specifically, what was the percentage change? Oh, I forgot something. Hang on, I'll finish writing this down, and then I've got to adjust this answer slightly. What was the percentage change from second meeting to third meeting? So of course, you're probably wondering why I didn't put increase or decrease here. So it's a 52% increase, right? I'm sure I said that in words, but the whole correct answer here that you should write down is a 52% increase. And why is it so important to note? Because it's like obvious that it's an increase, right? The number got bigger in part A. So why is it, if it's already obvious, why is it necessary to write it down? Well, because in the question, they just said, what was the percentage change? So when they're being vague about it, just saying change and not increase or decrease, they're implying that they want you to say whether it's an increase or decrease. All right, but now moving on to part B, it says we've got a third meeting now where only 31 people attended, and we want to measure the percentage change from second to third. So it's going to be important to note that we're not using the 25 anymore, because the 25 was from the first meeting, right? Let me scoot down right there. 25, this is first meeting to second meeting. Now we want to measure from second meeting to third meeting, which is 38 versus 31. So maybe I should write down explicitly that my original amount in this particular problem is 38, because I'm going from second meeting, which is 38 people, to third meeting. So my new amount is 31, because that's how many people attended in the third meeting. 31 people. So now my percentage change, or rather first my absolute change is going to be the absolute value of 31 minus 38. So now we're seeing why it's necessary to have absolute values around these problems, because this would normally yield a negative, right? But we don't want to deal with negatives here. So what happens is that absolute value takes care of it, of that negative for us. So we've got a -7 coming from this difference inside the absolute values, and then the absolute value takes care of that for us and just says, look, it's just 7, right? It's just +7. So you could take this to mean like that it doesn't really matter what order you subtract. Like you could just set it up as 38 minus 31, right? And you're not wrong, but you just need to be really careful about making sure that in your next step, when you're setting up your percentage change, that you're putting the right number in the denominator. So if you decide like, if it doesn't matter and it's just going to be a 7 anyways, then I'm just going to think of 38 minus 31 because I don't like dealing with negatives at all. Like I don't even want to see this intermediate step. I just want to think of it as 38 minus 31. That's okay, but you just have to remember that in this step, in the next step where you're setting up your percentage change, the original amount goes in the denominator. The original amount goes in the denominator, so that would be a 38, and then of course that difference goes on top. Okay, so 7 over 38 is going to be probably not a nice number, right? So I'm getting 0.18421, et cetera, et cetera. I'm going to multiply it by 100, and I'm going to round to the 100th place on my percent. So I'll say 18.42, yeah, just 42. Rounding down there. It's rounding down on that 100th place. And this is a decrease. From meeting 2 to meeting 3, there was an 18.42% decrease in attendance. Why do I say decrease? Well, because we went from 38 people at the second meeting to only 31 people at the third meeting. So there was a decrease. So in order to decide if it's an increase or decrease, you have to go and look at the context of the problem and decide what's going on. Okay, part C. Now we've measured from 1 to 2 and from 2 to 3. So you probably know what I'm about to ask. I'm going to ask you to measure from 1 to 3. Oops. What was the percentage change from the first meeting to the third meeting? Okay, so the numbers I'm measuring are first meeting, that was 25 people, right? Maybe it's helpful to write that down. And third meeting was 31 people. So I'm measuring from, so the 25 is my original amount now, and third meeting attendance 31 is my new amount. So I'm going to take the absolute value of 31 minus 25, which is just going to be absolute value of 6, which is just 6, right? So no worrying about the negatives here. This tells me, by the way, since this difference inside the absolute value is positive, that tells me that this is going to be a percentage increase at the end. But hopefully that makes sense just from the setup of the problem, going from 25 to 31 people. Now, are we expecting, so part A, so from 1 to Let me see if I can get it all on one page here. Nope. Okay, but well, anyways, part A was measuring from meeting 1 to meeting 2, and we got 52% increase there. Then meeting 2 to meeting 3, we got an 18.42 decrease. So do we expect there to be a relationship here? Maybe like, you know, subtracting these percents or something like that, maybe, but maybe we're not sure. Of course, we're going to calculate it here to see what happens. So let's see if we can find a relationship, and if not, let's talk about why. All right, so we've got a 6 and our percentage change. That 6 is our absolute change. So now our percentage change is going to be a measure of absolute change divided by original amount, which is 25, and then times 100%. And that's going to give me 24%. Just doing 6 divided by 25 and then times 100. And increase, right. Okay. So there's not a relationship. There's not a relationship between those 3%. So let me make a note of that. So why is that? Because you would think like that maybe they're related somehow. Oops. Okay. We cannot combine the percentages from part A and B to get the percentage from part C. Like you can't just subtract them. Like we can't do, you know, 52% minus 18.42% gives 24%. That doesn't work, right? So no, that doesn't work. So why can't we do that? Because it almost seems like it should, right? Because this is meeting 1 to 2, this is meeting 2 to 3, and this is meeting 1 to 3. So maybe there should be a relationship. Well, the thing is, why can't we do this? All of these percentages each of these percentages are measuring an amount taken out of a different, let me say it this way, taken out of differing totals. That's kind of the point of it. 52% came from 13 out of 25. The part B came from 7 out of 38, and part C came from 6 out of 25. 6 out of 25. They're measuring things from differing totals, right? Differing amounts, different numerators, and different denominators. If I wrote these percentages as fractions, then it would be clear why we can't add or subtract them, because they have different denominators. Now the part A and part C actually have the same denominator, so maybe there's something we could say there. But that central one has a denominator out of 38, right? So that's kind of why we can't add or subtract. They're measuring different things, so you have to be really careful with percentages. You can almost never add or subtract them, because percentages are measuring. It's really important to note that they're measuring things out of some total, right? And anytime you're doing that, then that means you're dealing with fractions. And anytime you're dealing with fractions, you have to be very careful about adding or subtracting them. The book gives one example of this. They say, and let's see, am I going to write anything down? Maybe I'll just describe it in words. It's on page 178. It says that suppose you were told, I will write it down, just the relevant stuff. Suppose you were told that 75% of people in Alaska favor free skis for school children. I don't know why they would need free skis. I don't know. Free skis for children. For school children? Probably. Yeah, school children. Favor free skis for school children. While 40% of people in California favor free skis for school children. So if you look at this data, you might accidentally assume that there are more people in Alaska that favor free skis for school children than there are in California, right? And you may, I said that out loud, and you may still think, like, yeah, that's true. I see it. That number is bigger than that number. There are more people in Alaska that want free skis for school children than there are in California. But what this really tells us is that there are more people proportionally in Alaska that favor free skis for school children than there are people in California proportionally to the total that favor free skis for school children. So what am I saying? It's very important how you interpret these percents, because what's actually going on is there are not more people in Alaska that favor free skis for children. And why is that? Well, because there's like no people in Alaska, right? The population of Alaska, I mean, there are people there, but it's low, right? Not even 1 million. Population. Now, the book is citing data from 2010, so we'll just use that too. Population of people in Alaska is 710,000. So maybe there are 1 million people by now. I'm not sure. And population of people in California is a little bit more at, where is it? 37 million. 37 million. So this 75% of people in Alaska favoring free skis for children, that's going to be 75% of 710,000, which is going to be 532,000. Whoops, 532,500 people. Okay, and the 40% of Californians that believe that children should get free skis is 40% of 37 million, which is going to be 14,800,000. Way more people, right? Way more people. Way more people. So what's the point here? The point is that you should be very careful about what your percentage is measuring, right? If the total is out of people in Alaska versus the total out of people in California, then maybe these percents don't tell you as much as you think they do. But what do they tell you? So the other point is to know exactly what the percents can tell you, and that if we're being very careful about how we describe it, the proper thing to say is that more people in Alaska, out of the total people in Alaska, believe that skis, school children should get free skis. like per person, right? 75 out of 100 people in Alaska favor free skis for school children, while only 40% out of, or rather, sorry, while only 40 out of 100 people in California favor free skis for school children. So there's nothing like wrong with this data, right? It kind of makes sense once you interpret it the right way. Like, you know, there's a lot more snow in Alaska, I guess, so maybe people ski more. Maybe school children have to ski to school in Alaska. I don't really know what the context, excuse me, what the context of this problem is. So it kind of makes more sense that per 100 people, there would be more in Alaska that would favor free skis for school children. But it's also important to note that that does not mean that there are more people in Alaska that favor free skis, right? There's only 532,000 people in Alaska that want free skis for children, while there are nearly 15 million people in California that want free skis for school children. Okay. So let's see. That's all I'm going to do for section 4.4, and that is it for chapter 4. So now let's get into chapter 6, which is geometry. And I do want to try and get as far as I can today in 6.1, just so that I can finish 6.1 and talk some about 6.2 in the video I'll make for Wednesday. And then Friday, we'll have more time to run problems from 6.2. And then, and also review for the exam on Monday. Next Monday, right? Okay. Or wait, is it next Monday or next Wednesday? Let me make sure. Oh no, never mind. It's next Wednesday. Oh, we have plenty of time. Let me see. 3 days to talk about this stuff. Is that? Oh yeah. You know what? You guys want to leave it for today? We have plenty of time. We have plenty of time to talk about geometry over the next 3 classes. For some reason, I was thinking the exam was Monday. It's not. It's Wednesday, the 3rd. Okay. So, are there any questions about percentage stuff? We got time to look at some homework problems or something. Yes, Kim.
I think that percentage was talking about per capita when it was talking about the 2 different states.
Yes, that's right. That's right. And that's, so I'm not saying that the percentage was wrong, right? It's about how you're right. You have to be able to bring that knowledge to it. And, you know, if a lot of you are like, well, of course, like, I understand that there are more people in California. So, you know, like, I get it. Like, then you're already bringing the knowledge to the percentages that point was trying to make. Right. So it's if that already makes sense to you, then that, you know, that little example may not have seemed necessary. And, you know, maybe more people are comfortable. So the book is like assuming that students don't know how percentages work at all. Right. That's why that example came up. But maybe more people are aware of percentages maybe nowadays because we see so much data nowadays, right? We see so much percentages online and news and, you know, crazy stuff on Facebook. So, you know, maybe we have become smarter collectively about smarter consumers of data, which inherently means understanding percentages a bit better.
I'm glad you said you was making a film for, a presentation for Wednesday, because at that time, I'm going to be in the doctor's office trying to get them to fix my knee.
Oh yeah, that's right. That's